Business Analysis Techniques. This is week 3. Welcome to unit 3 of Business Analysis Techniques. This is your online instructor, Diana Block, and I wanted to take a few minutes to go over some concepts you're going to need for the week 3 assignment. So we don't have a lot of time before this video ends. We only get 15 minutes using this program. So I want to get right to the homework assignment, and we'll start there and use that as a launch pad to talk about some of the concepts from Chapter 3. Chapter 3 is about decision making, and so we're going to look at several decision making tools and options that we can use as part of business analysis to make decisions. So in your assignment here, I've got a problem 1, and you can read the paragraph, what it's talking about, but I want to skip down to the questions, starting here, question A. What is the max and max decision? Max and max decision is the most optimistic decision available. So when you are considering what is the max and max decision, you're going to look at the decision that gives you the highest of possible payoffs. What's the best case scenario? And that is your max and max decision. So based on the information that you're given in the problem, if everything were to go as perfectly as possible and you would get the largest possible payoff, that is the decision that you would make if you were looking at your max and max decision. So then the next part says, what is a max and min decision? So the max and min decision is just the opposite. It is the most pessimistic choice available. So we're looking at the worst payoff alternative, or the minimum payoff out of all the alternatives presented here. So when you are writing down what is your max and min decision, you're going to look at, of all the information provided, which decision provides you with the worst or minimum payoff value, and that is what you will use as your max and min decision. Now, there's some other choices here. What's the equally likely decision? So let's talk about that. So with the equally likely decision, what you're going to do is find the average payoff for each alternative, and then select the alternative that has the highest average. So that means you're going to actually do some calculations for the equally likely decision. With the max and max and max and min, you're going to select based off the information given. With this equally likely, you're going to actually do some calculations. You're going to average the payoffs in each scenario. So you're going to average the possible payoffs for a small market, the possible payoffs for a medium market, large, and very large. So instead of just looking at the highest or lowest payoff in each one, you're going to actually average those. So if you're going to do this in Excel, you might even make a column here next to the data, and then put equally likely, and then calculate your average for each of these scenarios, and then your equally likely decision is the one that will have the highest average. And so then the last one says, what is the criteria of realism decision? And so that is explained in your textbook on page 69, and what we're talking about there is the weighted average. The criteria of realism is kind of a compromise between the most optimistic and the most pessimistic decision. And so you also have a formula that you're going to use to calculate that as well. So if you're doing this in Excel, you might want to add an additional column that's going to be your criteria of realism. And what you're going to do is take a weighted average of the best case scenario for each alternative and the worst case scenario of each alternative. So look at that formula on page 69 to make sure you're using the correct formula for criteria of realism. It's a weighted average of the best and worst scenario for each alternative. So you're going to do those calculations for part C and D, but remember, for every one of these questions, A, B, C, and D, do the calculations, but also don't forget to actually give your final answer. Sometimes people forget to actually give the answer. So going back up to the problem now, this person is trying to determine what size of a gas station they should open: a small, medium, large, or very large station. So for each one of these, your answer is either small, medium, large, or very large. Based on the different criteria given here, you're going to state which type or which size of station she should open based on either the max and max decision, the max and min decision, equally likely, or the weighted average, which is the criteria of realism. So that's how you're going to solve problem 1. And that information is discussed between pages 67 to maybe 70 in your textbook. So then we're going to scroll down a bit and look at problem 2. In problem 2, we're going to talk about the concept of expected monetary value and expected value with perfect information. So with the expected monetary value, you're going to find information about that on page 71 of your textbook at the bottom. And the expected monetary value is going to be determined by looking at the probability of each alternative that's available to you. And so you are going to do a calculation, and there's a formula that's at the very bottom of page 71, and then there's example on the next page on page 72. There's an example of that. So you're going to use a formula. So again, you may be completing this problem in Excel, and if that's the case, you're probably going to make a column right here next to the data and that says expected monetary value. And then you're going to enter your formula to calculate the expected monetary value of the sub 100, the Euler J, and the Texan. So you're going to calculate the expected monetary value of each of these equipment purchases. And again, it's a weighted value. And so the formula is on page 72. And we've also got some given information here that's going to help you with the formula. It says that he believes there's a 70% chance of a good market and 30% chance of a poor market. So that is going to factor into your formula, because look at here. If it's a good market, the sub 100 will have a $300 value. If it's a poor market, you're going to have a loss of $200,000 in value. So basically the short version is 70% chance of a good market times the $300,000 that you will get if it's a good market, plus 30% chance of losing $200,000. That's going to give you the expected monetary value. So you're going to use this 70% and 30% that are given here. You're going to plug that information along with the values in this table into the formula that's explained on page 71, 72. You're going to get the expected monetary value of all three of these pieces of equipment, and then you'll be able to choose for A, what's the optimal decision. So you want the piece of equipment, obviously, that has the highest expected monetary value. Now, the expected value with perfect information is the other part of this problem, part 2. And just like it sounds, the expected value with perfect information is the expected or the average return in the long run that we would get if we have perfect information before the decision has to be made. So to calculate that, we're going to choose the best alternative for each option and multiply the payoff times the probability that that would actually occur. So again, that formula, that exact formula, is on page 73 of your textbook. And so you're going to use this information. Again, you're going to use this 70-30 again. That's in part A. That's also going to apply to the formula in part B. And so you're going to do some short calculations to get the expected value with perfect information. And once you have that, you'll be able to determine the maximum that you would pay in this market. And the way you'll determine that is you will take the expected value of perfect information that you're going to calculate in part B, and you'll subtract from that the expected monetary value of the highest piece of equipment, or the piece of equipment that we've selected. So I know that's might be kind of muddy right now because you haven't read the chapter yet. That's why I want to make sure you refer to chapter 70 or page 73 to get the formulas. Know that it includes this information, this 70% and 30% that's in part A. And once you get the EVWPI, to get the max to pay, you're going to take the EVWPI and subtract the expected monetary value, and that's how you're going to get the maximum you should be willing to pay. So that's what we're working with on problem 2. Now, problem 3. Now, in problem 3, you're actually going to go back to expected monetary values. You're going to use the expected monetary values again on page 71, 72, 73. That shows you the formula for expected monetary value. And that's what you're going to use in problem 4. Or problem 3. It's just going to give you different scenarios, and you're going to calculate the EMV for several of them. And this is actually in Excel. I'm looking at a Word format of it, but your assignment I just pulled up, it is in Excel already, so you don't have to format any of this. But it's the same information. It's just going to be in Excel for you when you open it. So you're going to see this chart, the decision tree. And you see here the problems. They're just asking you to find the EMV at specific nodes. So this is going to be in an Excel format for you, but you're going to find the EMV, the expected monetary values. So you're going to make sure you look in the paragraph and see what the chances are of the different types of markets. So you see here there's a 90% chance that it'll be a favorable market, and which means it'll be a 10% chance unfavorable. And if the market survey comes back unfavorable, that's a 40% chance. So all of the numbers that you need for the EMV formula are in the paragraph. So make sure you refer back to that. And I'm looking at a different version, so these may be different percentages. The problem is the same. Make sure that when you open the assignment, you use the percentages that are in there. But point being, you're going to calculate expected monetary value. And then of the choices provided to you, you're just going to choose the alternative that has the highest expected monetary value for each scenario that you're presented with. And so that is the assignment. You're basically going to look at the concepts of, let me go back over it. You're going to go look at the concepts of maxim-min, maxim-max, equally likely, criteria of realism. And so that starts about page 67 of the textbook. Then you're going to do some calculations of expected monetary value and EVWPI, which is expected value with perfect information. That stuff starts on page 71-ish through about 73, 74. And then your last problem, you'll continue to do EMV calculations, expected monetary value. So make sure you use the formulas that are in the textbook for you and just plug in the percentages that are given in this particular problem. If you have any questions about this, of course, you can send me an email anytime. You'll get a quick response. It's helpful if you include your spreadsheet when you send an email. That way I can see what you have so far, or I can look at your formula to see if there's a problem there. Or you can always talk to me on Blackboard IM during office hours. So we look forward to talking with you this week, and have a great one.